Once in a while, we run across a science story that's hard to believe until you see it. That's how we felt about this story when we first saw human beings operating computers, writing emails, and driving wheelchairs with nothing but their thoughts. Quietly, in a number of laboratories, an astounding technology is developing that directly connects the human brain to a computer. It's like a sudden leap in human evolution, a leap that could one day help paralyzed people to walk again and amputees to move bionic limbs. As you will see tonight, the connection has already been made for a few people, and for them, it has been life-changing. Scott Mackler was a husband, father, and successful neuroscientist when he received perhaps the worst news imaginable. At the age of 40, he could run a marathon in 3.5 hours, but it was about that time that he discovered he had ALS, Lou Gehrig's disease. His brain was losing its connection to virtually every muscle in his body. The near-total paralysis would also stop his lungs. He didn't want to live on a ventilator, so 9 years ago, he recorded this message for his 2 sons.
I know the future holds lots of love and joy and pride, and that life goes on, and I'll be watching you along the way. And I love you very much, and I'll see you.
This is Scott Mackler today. His mind is sharp as ever, but his body has failed. Doctors call it locked-in syndrome. Scott and his wife Lynn learned to communicate with about the only thing he has left, eye movement.
He'll look at you for yes,
right,
and for no.
And for no, he looks away.
Yeah.
I see. It's cumbersome.
It is.
But recently, Scott found a new voice.
Can everyone hear the PC? I apologize for the quality of the voice.
Scott wrote these words one letter at a time with nothing but his thoughts and the help of what's called a brain-computer interface, or BCI. He wears a cap that picks up the electrical activity of his brain and allows him to select letters simply by thinking about them. Then the computer turns his sentences into speech.
I hate being helpless, and when other people put words in my mouth.
Well, this is a very unusual interview for 60 Minutes. We've done something that we never, ever do, and that is we've submitted the questions in advance because it takes Scott a little while to put the answers together using the BCI device. Scott, I understand that earlier in the progression of this disease, you said that at the point you had to go on a ventilator, you didn't want to go on anymore. But today you are on a ventilator, and I'm curious about what changed your mind.
Because I can still communicate.
It isn't fast. It takes 20 seconds or so to select each letter. Scott told us it took him about an hour to write the answers to our 16 questions. But he writes well enough to continue his research and manage his lab at the University of Pennsylvania, where he still goes to work every day. You use this system even to text your sons, for example. And I wonder what it would mean to your life today if the system somehow was taken away from you.
I couldn't work without BCI.
Couldn't work without BCI. What has it meant to your relationship?
Well, he's happier. He can communicate with not just us, but with the world. This gave him his independence, his working, intellectual, scientist independence back.
The system was developed by neuroscientist Dr. Jonathan Wolpaw at New York State's Wadsworth Center.
This is basically a standard EEG brainwave cap.
To understand how the BCI works, I asked researcher Teresa Vaughn to hook me up.
And you'll see their little white discs scattered around on your head.
Those discs are electrodes that pick up the faint electrical activity that brain cells create when they communicate with each other. Yeah.
Sorry.
It's a little cold. Teresa is putting a conductive gel on top of my scalp to help the electrodes pick up the signals.
All set?
All set. I'm thinking of the letters of a word that only I know. Every time the computer flashes the correct letter on the screen, I silently think to myself, that's it, that's the one. That feeling of recognition sets off a unique electrical pattern in my brain, which the computer picks up. Wow, this is remarkable. It worked the first time I tried it, without a single mistake. That is amazing. How about that? How about that? I never would have believed it. You know, I can imagine some people watching this interview are thinking to themselves, wait a minute, they're connecting the brain to a computer.
Mm-hmm.
Are we moving in the direction of reading people's thoughts?
Yeah,
Is this mind control around the corner?
No, it's not. It's certainly not mind control, and it's different from reading people's thoughts. It's important to realize that this requires the cooperation of the person.
As remarkable as this is, some scientists believe this technology is limited because putting electrodes on top of the scalp is like listening to a symphony from the street outside the concert hall. So what would happen if the electrodes were inside the brain? That's what they're doing at the University of Pittsburgh, implanting electrodes inside the brains of monkeys.
This is an array.
Andy Schwartz, a neuroscientist at the university, implanted this grid of electrodes. It's tiny, but there are 100 sensors, each listening to a different brain cell or neuron. It's like listening to the symphony of the brain, but now